In TypeScript, types are the foundation. Just like in JavaScript, we have basic types like strings, numbers, and booleans. But here's where TypeScript shines. By explicitly defining these types, we ensure our variables always hold the expected type of data. This simple practice can save us from many potential bugs in our code. Beyond basic types, TypeScript introduces more complex types like arrays, tuples, and enums. Arrays allow us to hold a list of items of a specific type. Tuples, on the other hand, let us define a fixed array with elements of specific types. Enums are a way to give more friendly names to sets of numeric values. Together, these types provide a robust toolkit for handling complex data structures. TypeScript also provides special types like any, unknown, and never. Any lets you work with a variable of any type, offering maximum flexibility. Unknown is the type-safe counterpart of any, requiring you to narrow down its type before use. And never is used for functions that never return a value. Understanding when to use these can help you handle edge cases with precision. Union and intersection types in TypeScript allow us to create complex type definitions. Union types, using the pipe symbol, let a variable be one of several types. Intersection types, with the ampersand symbol, combine multiple types into one. These powerful constructs enable more flexible and reusable type definitions. Interfaces and type aliases are core to TypeScript's type system. Interfaces allow us to define the shape of an object, making sure every object adheres to a specific structure. Type aliases, while similar, can define a type for a wide range of shapes, not limited to just objects. Both are powerful tools for organizing and enforcing type structures in your code. TypeScript excels in defining types for functions. Whether it's the parameters or the return type, TypeScript ensures your functions work as expected. You can also define types for higher-order functions and callbacks, making your code predictable and less prone to errors. In object-oriented programming, TypeScript brings a lot to the table. By implementing interfaces in classes, TypeScript ensures your classes meet specific contracts of structure and behavior. This makes your classes more structured and consistent. Generics are one of TypeScript's most powerful features, allowing us to write flexible, reusable, and type-safe code. With generics, you can write a function or a class that works with any data type while still maintaining type safety. This is incredibly useful in a wide range of programming scenarios. Even with TypeScript, there are pitfalls to avoid. Common issues include misunderstanding the difference between type assertion and typecasting, or mishandling "null" and "undefined". Another trap is overusing the "any" type, which can negate the benefits of TypeScript. Being aware of these pitfalls helps in writing cleaner, more effective TypeScript code. Let's apply our TypeScript knowledge in a real-world scenario. Consider a simple to-do application. By defining interfaces for our to-do items, we ensure each item follows a specific structure. This makes our application more predictable and easier to maintain. Such practical applications of TypeScript illustrate its power in everyday coding.